What's up, Algebra 2? Not sure how long the voice is going to last today, so I'm making a video as a backup plan here for you guys. We'll see what happens. Okay, so our first type of problem today, we're solving with logs, and instead of just evaluating and having both of these numbers given, okay, our x is going to be over here today. They're going to give us this number. So if you're good at reading it this way, you don't have to turn it around. Feel free to leave it as it is, but I'm going to flip it around. I like to flip it around, so it's the other way around here. So then when I read this to myself, it's 3/2 is the power of 9 that gives me x. So 9 to the 3/2 power equals x. Alright, two ways to think about that. Okay, we know the top number is the power, the bottom number is the root. So the second root, or the square root of 9, is 3, and then 3 cubed is 27. You can think about it that way and do it in your head. Or you could take the lazy way out, 9 to the 3/2 power, 27. Or 3/2 as a decimal is 1.5. 9 to the 1.5 power, 27. Okay, let's have you take a look at this one over here. Log base 16 of x equals 5/2. We'll hit pause here and give you a minute to do that one. Alright, welcome back. Again, I like to turn these around. 5/2 equals log base 16 of x. So 5/2, or 2.5, is the power of 16. That would give me x. Okay, again, the bottom numbers are root, so the second root, or square root, of 16 is 4, and then 4 to the 5th, tough one, 1024. Or we could also just type that into our calculator again. 16 to the 2.5, 1024. Okay, I think we might have a few exponential problems sprinkled in there today. Alright, don't hit the panic button because it looks different. You've done these problems before. You'll be fine. Okay, we're going to rewrite these common base. 1 over 2, I'm going to change that to 2 to the negative 1 to the x, and 4 is 2 squared. So I have a power, parenthesis power. This is when I multiply. So negative 1 times x is negative x equals 2. So positive x will equal negative 2. You've done those before. That was a couple sections ago. You'll be fine. Alright, next type of problem. These look scary, okay, but they're actually not bad. Log base 2 of x squared minus 4 equals log base 2 of 3x. So we have the same log base 2 and log base 2 of two different quantities. Okay, the only time that can be equal is if these two quantities are equal, because you're doing the same type of log. You're doing log base 2 to both of them. So the only time this is going to be equal is if this group is equal to this group. So x squared minus 4 equals 3x. Okay, we're going to bring that 3x over. Minus 3x minus 4 equals 0. Okay, factoring strategies. What multiplies to negative 4 and adds to negative 3? A negative 4 and a positive 1. What makes each one equal 0? Positive 4, negative 1. Okay, so my answers are 4 and negative 1. Now, the tricky part. You got to remember to test these, especially when there's a squared. Okay, especially when there's a squared part. Because when there's a squared part and you're using a negative, it's going to lose its negative sign, and that could really influence the answer. We'll see. So let's put 4 in. So I'm just going to do the quantities here, because we need these quantities to end up being equal and positive. Alright, so we're going to go with 4 squared minus 4, that's 16, minus 4, that's 12. And on the other side, we have 3 times 4, that's also 12. Okay, so if I put my 4 in, 4 squared is 16, minus 4 is 12. 3 times 4 is 12. So we'd have log base 2 of 12 equal to log base 2 of 12. That works. What about negative 1? Okay, negative 1 squared minus 4. Be smarter than your calculator. Negative 1 squared. When you're doing negatives squared, make sure we're using parentheses. That's going to be a positive 1. Minus 4 is negative 3. Okay, if I do 3 times a negative 1, I also get a negative 3. Alright, so they're equal, but they're negatives, and we can't have negatives. Okay, that's a domain error. So we're not going to use negative 1. X is just equal to 4. Alright, this part of the log got to be positive. Okay? So we can't have negative numbers in there. Alright, let's have you try this other one over here quick. Okay, welcome back. Let's see how we did. Just going to slide this one in, save a little bit of time. Alright, so it's the same strategy as last time. It doesn't matter that this is a really crazy number, 112 and 112. All we're doing is making sure that these two spots are equal. X squared minus 15 needs to equal 2x. We're going to subtract that 2x over, factor what multiplies to negative 15 and adds to a negative 2, negative 5, and a positive 3. Okay, so we have x minus 5 and x plus 3. What makes each group equal 0? 5, negative 3. Now we got to test them out. Okay, so if I do 5 squared, that's 25, minus 15, that's going to be 10. And then 2 times 5 is also 10. So we'd have log base whatever of 10 equals log base whatever of 10. Okay, they equal the same thing, they're positive, they're greater than 0, we're good to go. Alright, now the negative one. These are usually tricky, but sometimes they do work out, so don't just always assume you're going to cross out the negative one. Okay, negative 3 squared is positive 9, minus 15 is negative 6. And then on the other side, 2 times negative 3 is negative 6. So they're equal, but they need to be bigger than 0. We don't want negatives, so no, we're not going to use that one. X is just equal to 5. Alright, that's what we're doing today, equal signs. Tomorrow, day 2, is going to be inequalities. That's going to be the back side of this note sheet, so hang on to it for another day. Alright, we're going to be on page 480, 8 through 19. That should be another 11, 12 problems. Not too bad, very doable. Alright, there you go.